Hello. What we're going to be doing today is composing some functions. So we have a function here. When we see this function, another way of thinking about what's going on here is that f of blank, in this case equals blank plus blank squared. So when you see an expression like this, what you're actually doing is you're filling in the blanks. F of t minus 2. So we have a t minus 2 filling in the first blank plus t minus 2 filling in the second blank. Great, we just figured out what f of t minus 2 is. Now I'll tell you something right now. You may be tempted to take this and multiply it out and combine it with this, and sometimes that's going to be useful. But for right now, I'm not too bugged about it. So if you leave your expression like this, I'm happy. So let's do that again. What is f of g of t? Well, according to how this works, we're supposed to use g of t to fill in those blanks. So there's g of t plus g of t squared. So now we have to plug in what g of t is. That is 5 minus t plus 5 minus t squared. And again, I am not concerned about you not multiplying this out. As long as you're composing functions correctly, everything's great. All right, so let me erase what we got here, and let's actually do this with the g instead. So notice that if we do the same sort of blank thinking, we have g of blank is 5 minus blank. That's how the function works. So when we see g of f of t, we're supposed to have g of f of t, that is 5 minus f of t. And now we just have to plug in what f of t is. Now do be careful here when we're subtracting, especially since it's something complex. Put stuff in parentheses. Practice safe mathematics. There we go. That is g of f of t. Same idea. I can have g of t. I can put g of t inside itself. So following my blanks, what I have here is this should be 5 minus g of t. So that's going to be 5 minus, use parentheses, 5 minus t. And we'll do a little bit of simplification here. So that's going to be 5 minus 5. That minus minus comes together to form a plus. We have cancellation, boom, boom, and we're left with t. So there are 4 examples of how you can use function notation to handle things like complex function expressions and composing functions.